Welcome back. In Python, just like in many other languages, there are libraries which appear and disappear. But there are also libraries which are getting more and more popular every year, and every year becomes better, faster and stronger. One of them is Pandas. Powerful and simply amazing library to read, transform and analyze data, kind of the Swiss knife of the data analytics. Whenever you have a data in the file or maybe a database, and that data can fit your computer, that it's good enough for Pandas to do the magic. If the data is too big for your computer, then probably you want to go for something like Apache Spark, but it's totally separate discussion. On the other hand, if the file is very small and you just want to do ad hoc analysis, then maybe Excel is the right choice. For everything in between, Pandas is a great fit. Today we are going to do the introduction to this library, something what I would like to get when I was starting to learn it. We will read the data, filter, view it, summarize it, group it, merge it, or even do some simple charts. So later on it will become way easier to use official Pandas documentation, which by the way is really good. Okay, let's get started. At the beginning, first things first, we want to make sure that the Pandas is installed on our PC. If you have a Jupyter notebook with Anaconda, just like me, Pandas is already installed and there will be nothing spectacular happening here. The next step is to import our library. The standard name under which people are importing Pandas is PD, so we will do this as well. And now it's a time to talk about the most important data types in Pandas. One is called series, the second one is called data frame. When it's going about series, we can compare it to one column from the Excel. In this case, we will create the series using the function series from Pandas based on the list of the 5 elements. Control Enter, and then we can perform in a very easy way different operations like multiply by 10 or make sure that all the numbers are above 0, or we can use a very handy function describe to get a basic statistics about our series. As we could see above, on the left we have something what is called index. The way the Pandas creates the default index is assigning the number starting from 0. Then with the index we can easily refer to our row. We can also change those names and give our own, like here. And now we can refer to the last row by giving the name of the series, square bracket. We will be using the square brackets a lot in Pandas. Pandas loves square brackets, and the name of our index, so here, and as the result we will get a number 7. Now it's a time to talk about the second data type in Pandas, the data frame. We can compare the data frame to the whole table in the Excel. There is a plethora options to create a data frame, and we will go just through some of them. This is the way we can create a data frame based on the list. Here is our list with the name and the age of the people, and we use the function data frame from the library Pandas, convert our list to the data frame, and then we change the names of the columns to be more meaningful, and we display our data frame. Standard way of calling the data frame is df, so we press Ctrl Enter, and here comes our first data frame. Another way to create a data frame is based on the dictionary. As the key we give the column name, then as the value the list of the values, and again here the column name, in this case city, and the list of the values. Then we use the same function as above and we create our second data frame with the names and the city. Another way to create the data frame, very powerful, is based on the data from the database. We have a function which is called read SQL. We pass the query which we want to execute, and the link to the connection to our database. In this case, it's an SQLite database which I have on my computer. Control Enter, and we can display the content of the data frame. We have some Bitcoin prices over the time. Another way, very popular, is creating the data frame based on the files. We can create the databases based on the plethora of the file, which we are going to see in a second. In this case, it is probably the most commonly used function, where we create our data frame based on the CSV file, which you can find under this address. Address will be under the movie, so you can type it by yourself. And as the results, we have, let's display it, we have a data frame with 227 rows multiple countries, information about the region, population, and some other informations. We have number of other functions to read the data from the files. We can see it by writing pd.read. I press tabular and I see that I can read the data from the CSV, Excel, I can read it from JSON, from Parquet, and few other data types. What is worth knowing about that functions, read CSV, read Excel, and so on, is that those are very advanced functions, meaning they have a plethora of options to read a data. If you have a file where you are missing some rows, or you don't want to read the last row, or you don't want to read all the columns, probably there are already appropriate options in that functions which will allow you to skip the data or to fix some data on the fly. All the details can be found in Pandas documentation. Now let's move forward. So we have our data frame. How to display its content? There are many ways of doing that. First option we already saw above. This is just by typing the name of the data frame, and as the results we are going to get a first rows and the last rows from the database. Another way is to use the function head, which will return 5 first rows from that data. Very similar function tail will return 5 last rows from that data frame. If we want to see some specific rows, let's say between 10 and 30, we can use again square brackets, and just like in case of the list, we specify which rows interest us, and as the results we just get this part of the data frame, nothing more, between 10 and 30. If we want to get some specific columns, we can pass the list of the columns names which we are interested in, Control Enter, and this is what we get. If we want to get 3 first rows and the 3 first columns, we can use the function ilog, like here. Or if we want to get the 3 first rows and the columns which name is the following, we can use the function log. This was ilog, this is log, Control Enter, and this is the results. We will not be using functions ilog and log a lot in this episode, but it's worth knowing that those exist, and once you will become more proficient in using Pandas, you will be using those functions a lot. We know how to create our data frame, we know how to view it. Now it's time to perform some basic operations like modifying the columns. We will create a copy of our data frame with only those columns, Control Enter, we use function copy, and we have a subset of our data frame. One of the things which we see at the beginning is that population is not readable. We would way more prefer to have it in the millions of people. What we can easily do by dividing by millions, or we can very easily create a new column. Let's say new column equals to 1, Control Enter, and let's see our data frame now. This is how it looks like. The population has become way more readable, and we have created the new column. Very simple. The next thing to learn about the data frame is how to filter it in a little bit more advanced way. There is a very powerful mechanism in the data frames in Pandas which is called mask. Here comes the example of the mask. We are giving the name of our data frame dot and the name of the column. In this case we just gave it like here. We could also give it in the square brackets. If we write such expression, this is what is our first mask. As the result of that expression, we are going to get a list of the false and true value, depends if the condition has been met. Let's see it. We get exactly the same number of the rows here as we have in our data frame, just value false and true, and the true is for the row where the condition has been met. So in our case we have only one true, probably. Definitely we have one for the first row. That means that the population of that row should be exactly like this. Let's check it above, and here it comes. For this one specific row our condition has been met, so as the results we got false everywhere else, and here we got true, just like here. And this is a very powerful mechanism which is called mask. Now we can use our mask to filter the data from the data frame. Here are 3 examples how we can do that. All the 3 gives exactly the same results. The first example, we have the name of the data frame, and in the square bracket we put our mask exactly like above. The second one, again, the name of the data frame, square brackets, just this time we are referring to the column, not like here by a dot and the name of the column, but the square brackets and the name of the columns. And the third way of creating the mask, again, all those three will give exactly the same results, is we define the new variable which consists our mask, and we pass over this variable to the data frame in the square brackets. Let's execute it and let's see what will happen. As the results of applying our mask to our data frame, we got a row where this condition has been met. So this was the first very simple mask. Mask can be more complex, like in this case where we have two conditions. First one is that population should be about 100 millions, and the second one is that population should be above 150 millions. If we apply that mask, as the result this time we should get a few rows. We have 5 countries where the population is between 100 millions and 150 millions, and those are countries. So masks are very powerful mechanism in Pandas and similar to if conditions. Just in this case, we don't write like in if condition we would write and, just we use the and symbol. Now the next thing to learn in Pandas is how to summarize and group the data. Everyone who was doing some pivot tables in the Excel or was using SQL in the past will be looking for the way to do some statistics and some aggregation. As the first example, we create a very simple statistics, just a sum, max, min and min, for the column population of the whole data frames, and this is what we get. Very simple way, but also very simple statistics. What is more interesting, we can also easily do group by grouping per different columns. So we want to calculate the same statistics, just this time per a region. This is what we get. Not very handy, not really readable, but it's worth to know it. Now the things becomes more interesting. We don't have only the function group by available, but we have also the function aggregate. There are few ways of using the function aggregate. I will show you the 3 most common. The third one is my favorite. The first way to use the function aggregate is to pass in the list the statistics which we want to apply on that column and aggregate the data frame but that column. If we execute it, we get a simple data frame. Region has been set to the index, and we get a 3 column names which corresponds to the type of the operations times type of the function we have execute on the column population. So we have a minimum population in that region, maximum, and the sum of the population in that region. We can already see that Asia is having the largest, most likely the largest population from all the regions. Another way of using the function aggregate, which gives a little bit more control over the data because we can control the name of the columns, is this way. We don't pass the list of the function we want to execute, but we pass the dictionary in which we are saying that we want to create the new column which will be based on this function, and that's the second column we want to create based on that function. We want to apply it to this column and of course group it by the regions. So in a sense the same calculation as above, just written differently, giving us a bit more control over the outcome. This is the outcome, so we have 2 columns created with the names the way we want it. And there is a third one. The third way of creating the aggregations, my favorite one, giving me the most of the control. We again group data per region, call function aggregate. Just this time we are saying that this is the column I want to create. I want this column to be based on this column, and that's the function I want to execute. The same here, that's the column I want to create based on this column, that's the function, and this is a third column I want to create based on this, and that's the function I want to execute. As the results, this is what I get. Region is set to the index, and I have a maximum population in the region, minimum population in the region, and the number of the countries in those regions. Moving forward, sooner or later we'll be in the situation that our data will not longer be in one file but in multiple files, and we will be looking for the way to merge it, which is a nightmare in the Excel. In Pandas, we have a very similar way to merge different data sources as in the SQL. Let's check how it looks like. At the beginning, we created two data frames. Those are exactly the same data frames as we created earlier. One is having the name and the age. The second one is having the name and the city as the columns. Some names are the same in both data frames. Some are unique, exist either only in this data frame or only in this data frame. Now, how we can merge it? There's multiple ways we can achieve it. For the most popular one is to obtain the common part. So we want to get the people who are in both data frames and we want to see their age and the city. For that purpose, we are using a merge function from the data frame, and in the merge functions we are giving the names of our data frames. This will be our left data frame and this is going to be our right data frame, what we will see in a second. Then we are specifying the parameter on, which is the information, what is the key, on which column we want to join those two data frames. So of course in our case is a name, and if we execute it we get two names, age and the city, because both of those two people exist in both data frames. If we would like to get all the names from the left data frame, then we can specify parameter how left, and as the results we are going to get all the names from the left data frame. So this is the left data frame, and when we have the people in the right data frame, that we have the name of the city, otherwise we got the null value. This is the null value in Pandas. Similarly, this is how we can get all the data from the right data frame, and if exists we will have the age from the left data frame, otherwise we will have a null. And the fourth very popular way is of getting all the rows from all data frames. So now we have 7 rows. And the last thing to mention here is that Pandas cooperates excellent way with the powerful library to generate the charts, which is called matplotlib, and with the use of both we can easily different charts. Like in this case, just this one is really ugly. It's because I haven't set up any parameters. By playing a little bit with it, we can achieve really nice results, but it's a separate topic and very good excuse for me to create another movie. I hope that this will help you start with Pandas. Those were very basic operations. Pandas is pretty extensive library. More information you can find on the Pandas official documentation. There are some really good tutorials. Otherwise you will become better with the time. You really need to get some files on your computer and start analyzing. This is the best way to learn Pandas. That's it for today. Thank you very much for your attention and see you soon.